All right, let's start working through the problems on page 5. So, page 5 of the study guide. So problem number 15, we're continuing to work on factoring. Part A, I would actually normally do this as a factor by guess and check. I'll go ahead and show the process of doing the AC method for any of you who prefer that one. If you do guess and check, just kind of skip forward a little bit until you can check the answer. So AC, you're going to take your A value times your C value, which in this case is 6 times -3, which is -18. So what I want to figure out is what multiplies to -18 and can add up to 17. Now, the only thing that's going to work here is -1 times 18. That's it. So I'm going to split the middle term using these two numbers I just found. So -1x plus 18x minus 3. Now, we did factor by grouping in one of the previous videos, might even been a couple of the previous videos, but I'm going to split it. So I'm looking at just the first two terms. They share an x, so 6x minus 1. The second two terms share a -3. Nope, they actually share a +3. So 6x minus 1. 6x minus 1 and 6x minus 1 are identical, so I'm going to factor out those common terms, leaving behind x plus 3. So that's the factored form for part A. I'm going to go ahead and slide over to part B. First thing I'm going to do is look for a GCF. 3 and 75 can both be divided by 3. So x squared minus 25. X squared minus 25 is the difference of perfect squares. So x minus 5, x plus 5. What I just did to do that factor is I took the square root of x squared, x and x. Square root of 25 is 5 and 5, and one of them is positive, one of them is negative. Order on the positive or negative does not matter. Let's see, so that's that one. Part C, kind of a weird little problem here. We're used to dealing with squares, quadratic problems, but what you can do, because this is x to the 4th and then x squared, you can actually kind of pretend that this is a squared problem. So I'm going to split it as x squared and x squared. So when those two multiply together, that would get me x to the 4th. So let's see, what multiplies to -12 and adds up to +4? How about a +6 and a -2? So 6 minus 2 is 4, 6 times -2 is -12. Neither of these two terms can be factored further, so I'm going to go ahead and leave it as it is. So that's part C. Part D is probably the easiest one out of all of them. There is no GCF here. This is a straightforward quadratic. What multiplies to -18 and adds up to -7 is what you're looking for. So x, let's see, -9, +2. And just for the note, you were trying to multiply to -18 and add up to -7. So that's the last of the factoring for at least those problems. Let's slide on down to number 16 here. And these were the word problems that we ended the unit with. All right, let's annotate this problem. Cost is $1,000. Current cost of $5 per person, 100 people go there each month. The owner estimates that for every 20-cent decrease in ticket price, 30 more people will go to the arcade. So let's make an equation here that represents the profit. So P of X, I tend to put P of X because that reminds me it's the profit equation. It's going to be the price per person times the number of people minus the cost. Now, this is not, we know this isn't going to work. Like 5 times 100 means that this guy's making no profit, because that would be $500 a month minus the $1,000 it takes to keep it open. He's losing money every month. But he thinks that if he takes his price and drops it, so decreases by 20 cents a month, all right, for every one of those, he believes 30 more people will show up. So if he changes this once, he changes this once. And so this is going to end up being the profit equation. Write an inequality that represents the arcade making profit. So this exact profit equation, as long as you make anything more than $0, you are making profit. So we're going to say this is greater than 0. Determine the price the arcade can charge for tickets to maximize their profits. Now, this is going to go into Desmos. Now, if you prefer Calculate 84, you can absolutely use it, but I'm just going to type in this expression minus the inequality, so this expression, into Desmos. I'm not going to do any multiplication. As it's written is what I'm writing down. So 100 plus 30x, close the parentheses, and then subtract 1,000. Okay, so basically I want to take this this section and I want to eliminate that. I'm not looking at it right now, so I'm just going to do the double bars. Now, one thing I'm going to do is I'm going to kind of pinch this in so I can start seeing the equation better. There we go. All right, so I can see that there is a maximum profit here at some point. So let's see if I click on it, and this very top point is the one I want to look for. All right, so we're going to take this x value and we're going to round it. So 10.833 is going to turn into an x value of 11 if we round it. Determine the price. Now, if we look at this inequality, this first part was the price. The second part was the number of people. So we're going to do this price here, 5 minus 0.2 times 11. So I'm going to open up Desmos again to grab the calculator function. And let's see, 5 minus 0.2 times 11. So if the arcade charges $2.80 per person, they should be able to maximize their profits. All right, so I'm going to go ahead and get rid of Desmos here. And that is the end of page 5. I will make a separate video for page 6. If you have any questions or concerns about anything,